Hello and welcome to this quick Scala tutorial. I wanted to record a video showcasing how you can use the idea of deferred values, which are actually technically called thunks in functional programming, to create functions that actually do things sort of that are a little bit unintuitive but can actually be quite interesting. So we're going to create a countdown function, and the basic idea of the countdown is that the function will count down from whatever specific value we give it, whatever count we give it, and once it's reached 0, then we'll actually execute a block of code. And there are a few different ways that we can do this. We can use callbacks, but we can also use deferred values to essentially say that whatever the value of this block of code is, I don't want you to evaluate it until I actually use it. Okay, so let me just start with the basic outline of the function. So we're going to call this countdown, and basically we're going to take some count, and it's just going to be an int. We'll just keep it simple here. And then again, this is just going to print down the count and then execute the block of code. And presumably, you know, the block of code is just going to execute. It's going to have some side effects. Maybe it's going to print something like lift off, or it's going to say, you know, hello world at the end. But basically, the value of this countdown function is just going to be unit, right? We're just using it for its side effects. Okay, and so the basic idea here is that we're just going to have some kind of countdown functionality. So basically we would say something like, okay, well actually we'll use match. Let's use match on count. So we're going to match on count. In the case where count is 0, then we're going to actually execute this functionality. Now I just want to use some sort of placeholder here. We'll just use the unit value here because we'll actually get to what that block of code is that we're going to execute there in a moment. But the other case, of course, is just that it's any other value, and of course, I guess we'll just assume that the value is positive. Basically, at this point, then we're going to print. We're going to print whatever that count is, okay, and then we're going to just call countdown again, but with a new decreased count. So it's true if the count was negative. I guess we could say if count greater than 0, and then case if count less than 0. Here we could, I don't know, just I don't know what you want to put here. We'll just put the unit value. So maybe it does nothing if the count is less than 0. That's easier than throwing an exception or something like that. Okay, so now what do we actually want to execute here? Well, we want to execute something that we are actually given. Okay, it should be generic. We should be able to call a countdown to do anything. A countdown to launch the missiles, a countdown to lift off, a countdown to hello world, right? So what we want to do is we want to be able to take some block of code. Okay, now the typical way that this gets done, like the way that you would do this in a language like JavaScript, is that you would actually get a callback, right? So you would take a function that was passed in, and you would call that function. And we can do that in Scala, but we could do one better as well. We can actually say that we're going to take, we're going to call it launch. And instead of having a typical value, instead of having a typical unit value, right, which obviously if we were to just put launch here, that would compile, we're actually going to have a deferred unit value. And the way that we actually signal that is by putting this little arrow in front of the unit. And what basically that says is that when we pass in a value for launch, that value, whatever it is that we get put in, well, basically we'll put an expression in. That expression will not be evaluated until we actually use launch. Until we actually need the value of that expression, it will not be evaluated. Which is perfect because it allows us to pass in code that, again, we only want for its side effects, not for its actual value. We know what the eventual value is, it's just unit. No one cares what the value is. What we care about is the side effects. And so instead of executing the block of code that we pass in, instead of executing the expression at the time that we call the function, it will actually only execute it when we use the value, which is when the countdown reaches 0. So this is a very, very powerful idea actually, and you can use it throughout the language of Scala, but here we're going to just show a very practical example. So if I call countdown with launch of, and this is important actually, we're using keyword arguments here, so I'm just going to leave this as is, and actually I'm not being totally correct here. Launch should be unchanged. If we wanted to, we could do like a sub function that only handles the count. That would maybe be a little bit more straightforward, but we'll just keep it simple. Okay, so basically we want to pass in now our block of code. So what is our block of code? Well, it can be anything, and that's the magic, right? So I can say, okay, we want a block of code that's going to, I don't know, maybe it'll do two things. I'll print maybe and then lift off. Okay, so it'll print actually both statements. And again, the value of this expression, if we were to evaluate this expression, if we were just call this without, and I'll show that in a moment, if we were just evaluate this expression, the value of the expression is just unit, right? Anything that we put in here, whether it's print or launch the missiles or anything, it will just be, again, the value of the last expression, which is just going to be unit in this case. And that's what we define, that's the type we define. But we don't actually want the unit value, right? There's no information in the unit value. There'd be no reason to pass around that unit value. We might as well just put, what we put here, we might as well just put the unit value directly. But what we're doing is we're carrying these expressions around in this block, and we're going to execute them only when we actually want to, so that we get the side effects at the right moment. Okay, and the count we'll just say is 10. Okay, and now this is oh, hang on, not enough arguments for method countdown. Oh, okay, sorry. Alright, so this should just actually evaluate in the worksheet, and then we'll see in this console output, we'll actually see okay, actually did not put the right you've got to actually follow prefix strings with this S for string interpolation, and the way that works is actually quite simple. You just put a $sign in front of an expression, and if the expression is just like a variable, you can actually just put a $sign in front of the variable. If the expression is more complicated, you have to surround it in curly brackets. Okay, so that's just a little tutorial on string interpolation in Scala. It's actually really great. Okay, well, let's try this one more time with the string interpolation, and we should see 10, 9, the full countdown, and only at the end of the countdown do we see these two statements executed and liftoff. Okay, perfect. And again, that's because we've given it a block of statements, so this is one expression, but it contains multiple expressions within it. The value of this expression is the final expression, but every expression is actually evaluated in the block in sequence. Perfect. So now let's look at what happens if we just make one minuscule change. We just get rid of that arrow. It seems like everything's the same, and in fact everything will type check, but we'll get a very different output. Okay, and you can see that we actually get this and liftoff to begin with, right, which does not look right at all, and I'll explain why that is. Scala is eagerly evaluated, which means that when we call this function, we're calling it with two arguments, right, and two expressions which represent the values of those arguments. Those expressions, both the 10, which just evaluates to itself, right, and this block, evaluate until they become a value, and then only those values actually go through to the function as arguments and then are used in the body. So right here, launch in this case just becomes, it is actually just the unit value here, right? It's not being evaluated. It's already been evaluated when we called the function. We can see that because as soon as we call the function, we get both of these expressions evaluating. That is, both of these functions are called, right? If you want to talk about kind of traditional programming parlance, both of these functions are called. In Scala terminology, they're both evaluated, and so we get the side effects that occur when they're evaluated before we even get a single number in the countdown. Okay, so what we want to do here is we want to defer. That's why we put this little arrow in front, right? That's not just kind of for fun. That's to defer the evaluation so that it is only evaluated when we actually use the value, right? All we're doing here is we're just passing it along. We're just passing it along. We're not using it anywhere until we get to the case of 0. Okay, and to even like further drive this home, we can just make this negative, and you'll see that in fact this is never evaluated, right? Let's just see what the output is. There is no output. It gets rid of the window because literally we never reach this point where the case is 0. It says, hey, the count is negative, so we just finish the execution by returning the unit value. So great usage for deferred values. It's very simple. You don't have to, what's so great about this is actually, let me just show you how simple this is literally. So I can just say launch is println. We don't have to do a whole block. We don't have to make it complicated, right? Let me just show you how simple this is, right? So I can literally just say, okay, that the value of launch is println, and it seems ridiculous. It's like, what's going on here? We're passing in a statement, and again, if you're thinking from that traditional kind of programming perspective, this code looks ridiculous, right? It looks like we've got a statement, and we're saying that the value of the argument is the statement, and what in the world? But remember, println is just an expression like any other, just like 10 plus 3 or anything. Okay, it's just an expression that when it is evaluated has a side effect. But because we're deferring evaluation by using this arrow, it is not evaluated as most arguments are, as this 10 is when the function is called, or rather before the function is called, right? It is only evaluated when we actually use the value in the function body. And so we're able to just write these super simple, in Python or in other languages you have to create, you have to, now I'm just going to write this as a comment, you have to create some sort of, launcher is, you create some sort of anonymous function, and then that function in the body would have to be called, and it's just this kind of this extra degree of complexity that you're always having to kind of step back and think about. Oh, I've got to create a function, and I've got to embed this function in another function. It just seems crazy, right? The simple thing that you can do in Scala is you can just defer evaluation so that you can pass it in just like any other value, just as simple as you like. And again, you can even pass in a block like we saw of multiple statements. So really great feature of Scala. It's one of the most powerful things really in Scala, is this ability to just kind of totally control things like evaluation, and really fine-tune your program so that your program's doing exactly what you want it to. You don't have to jump through all these hoops to try and express something that really, when it comes down to it, can be very simple. Okay, so I hope you enjoyed this video, and yeah, definitely play around with this deferred evaluation. It's really powerful, especially when you deal with kind of callback functions and side effects and that kind of thing. That's when it gets actually really interesting. One little side note is that this def keyword is actually itself deferred evaluation. It's deferring the evaluation of the function body. The reason we do that is just to basically because it's a function, we don't need to evaluate the function body until we actually need to use it, like here. Okay, I hope you enjoyed that, and thanks for watching.